Okay, let's do another comparison test example. Okay, I've got some trig here. So, as usual, I'm going to go on the right here and do some thinking in a thought bubble. Think. So, sine. What do I know about sine? Well, -1. This is the first thing I know. Why did that pop into my head? Well, I'm thinking comparison test. Comparison test requires an inequality. And what inequality do I know involving trig or involving sine? Well, it's this one right here. Okay, when you square, you get something between 0 and 1. Okay, and n is an integer. Okay, n is an integer, so if you think about it, this is actually strict here. It's also strict here. Because when n is a positive integer, okay, n will never equal pi over 2 to give me exactly 1 for sine of n. So no worry about that. So sine squared is less than 1. Okay, so I'm thinking, so this suggests a comparison to 1 over n squared plus n, which is going to be very similar to just 1 over n squared when n is large. Okay, so this is just me thinking, strategizing. How am I going to approach this? Well, I'm going to take my awkward summand and try to compare it with an inequality. Try to compare it with an inequality to just 1 over n squared. So that gives me a goal to shoot for. So sine squared n over n squared plus n. Now, which way do I want the inequalities to go? Well, I'll just remember that summation 1 over n squared is convergent, right? So that tells me I want the inequalities to go. Oops, no. See, I did the wrong way. Gotta be very careful. You want it, I wanted something bigger. Okay, all this thought bubble, the thought bubble tells me that I'm expecting convergence. So that's worth repeating. The thought bubble tells me I'm expecting convergence. And if I'm expecting convergence, then my inequality should be going this way. So sine squared is less than 1. And for now, I'll just leave the n squared plus n. And what happens when you just drop that n? Is this true? Yeah, it is true because here the denominator is bigger than here. So let me recap my inequality. The numerator here is bigger than the numerator here. That proves the first inequality, this one. And the denominator here is bigger than the denominator here. And that proves the second inequality. So maybe you could write that if you wanted to write that down. You could say n squared plus n is bigger than n squared. Here you have sine squared n is less than 1. All right, continuing my demonstration, I established this inequality, and we know that this series is convergent because p is bigger than 1. So summation sine squared n over n squared plus n is convergent by comparison test.